back to another exciting day of Peak Flicks Math with the one and only Mrs. Dennis. I am so excited to see you today as we learn more great strategies to help us become better mathematicians. So are you ready for another excellent day of teaching and learning? Great. So let's dive into another exciting day of Peak Flicks Math. So we've been learning lately about fractions, and a great tool to help us learn about fractions is using slices of pizza. How many of us like pizza? I know I do. And so looking at pizza is a great way to learn fractions. So let's take a look at our objective for today. Our objective says, I can recognize and show that equivalent fractions refer to the same point on the number line. So today, our goal is to understand and show what are equivalent fractions and how do we know and how does a number line help us to recognize what equivalent fractions are. So before we even get into our lessons for today, you know we have to review our fact fluency. Absolutely, because when we are fluent in our math facts, it just makes us that much better at being better mathematicians. So today, Miss Dennis is going to show you a great trick to help you with your 10 times tables. Are you ready? Excellent. I love that. So today, to help us with our tens times table, we're going to learn a little trick. So to multiply whole numbers by 10, put a 0 after them. Let's say that together. Are you ready? To multiply whole numbers by 10, put a 0 after them. So what do we mean by that? Well, let's take a closer look at this strategy to help us with our tens times tables. So in your notebook, I want you to write the numbers 1 through 10, okay? So you're going to write 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So when you multiply these whole numbers by 10, you put a 0 after them. So, what do you think that we're going to do next? Yes, you got it. All we're going to do is put a 0 right behind our whole numbers. So you're going to put a 0 after the 1, 2, 3, 4, 5, 6, 7, 8. Ooh, I got to catch my breath. 9, 10. Great. And guess what? That right there is your tens times tables. Let's take a closer look, okay? So we have 1 times 10 is 10. 2 times 10 is 20. 3 times 10 is 30. 4 times 10 is 40. So, let me ask you, what would be 8 times 10? You got it, 80. What is 5 times 10? You got it, 50. What is 10 times 10? Yes, 100. And this is a strategy to help you with your tens times tables. So now that we learned this strategy, I'm putting you to the test. Are you ready? Okay. So now Miss Dennis is going to give you some tens times multiplication facts, and I want to know how quickly you know your tens times tables. Are you ready? Okay, great. Here we go. So let's look at the first one together. Can you tell me what is 10 times 3? Excellent. 30. 10 times 3 is 30. Because remember, all we do is put a 0 after the whole number. What about 10 times 5? Oh, yeah, we did this one. Excellent. 10 times 5 is 50 because all you do is put a 0 after the whole number. What about 10 times 7? Excellent. 10 times 7 is 70. What about 10 times 9? Excellent. 10 times 9 is 90. Isn't math fun? And these are great tricks to help us when we are doing all of our multiplication facts, especially by 10. So now let's look back at our objective for today. Our objective says, I can recognize and show that equivalent fractions refer to the same point on the number line. So I know what you're thinking, and let's do a little review. Well, what is a fraction? Well, a fraction, and Miss Spanish is going to move herself down here so we can see a little closer. A fraction is part of a whole number. So let's take a look at equivalent fractions. So equivalent fractions, and I'm just going to make myself a little smaller so we can see. So equivalent fractions on a number line are fractions that are the same shaded of a whole number. And on a number line, it refers to the same point on the number line. So let's look at this a little bit closer. So when we think about equivalent fractions, what word do we hear in that word equivalent? Equivalent. Yes, you got it. You hear equal. So if something is equal, that means it is the same. Yes, it's the same. So when you talk about equivalent fractions, it's the same amount of the shaded area. So in a figure like this one at the top, we see that it covers the same size and the same area of a whole number. So if we look at our first circle here, we see that half of this circle is shaded. But if it's broken into 4 parts and 2 are shaded, well, we still see that half of the circle is shaded. And if you take that and you break it into 8 parts and you shade in 4 of those 8 parts, then we still see that half of the circle is shaded. And so 1/2 is equivalent or is equal to 2/4, which is equivalent or equal to 4/8. When we look at a number line, we know that fractions are equivalent, or you got it, equal, if it's on the same point. So if we look a little bit closer here, we notice that 1/2 is on the same point as 2/4, which is lined up with the same point as 4/8. And so because all of these are in the same spot, then we know that they are equivalent fractions. Okay? So let's take a closer look at our strategy. So equivalent means equal. Excellent. Absolutely. So when 2 fractions are equivalent, that means they are the same size or on the same point of a number line. So I have a question. Are the 2 fractions equivalent? Well, let's take a closer look. We have here that we have a number line broken into thirds, and we have another number line that's broken into 6. And they're asking us, is 2/3 the same as 4/6? Are these 2 fractions equivalent? Well, let us see. If we look at this number line, are the 2 points lined up together? Yes. So 2/3, is it equal to 4/6? Yes, absolutely. Because if we look at our number line here, they are lined up in the same point. So that means they are equivalent fractions. Remember, equivalent means equal. You got it. So if 2 fractions are equivalent, that means they are the same size or they are on the same point on a number line. So, are the 2 fractions equivalent? Well, let's take a closer look. We have a fraction, a number line that is broken into fifths, and we have another one that's broken into tenths. And if we look, they're asking us, is 1/5 equivalent or equal to 2/10, right? So let's look at our number line and let's look at these 2 points. If we look at our 2 points on the number line, are they the same point? Are they lined up together? Yes. So we can say that 1/5 is equivalent to 2/10. Remember, equivalent means equal. You got it. So if two fractions are equivalent, that means that they are the same size or on the same point on the number line. So are the two fractions equivalent? We have a whole that's broken into two parts, right? Into halves. And we have another whole that's broken into eighths. And we want to know, are these two fractions equivalent? Is 1/2 equal to 3/8? Well, let's take a closer look at our number line. If we look here, what do you notice about these 2 points? Yes, you got it. 1/3 is smaller than 1/2 because they are not lined up on the same point on the number line, right? They kind of like have a slant. They have a diagonal. So does that mean that they are equivalent? No, absolutely not. We know that 1/2 is not equivalent to 3/8 because they are not on the same point on the number line. So now that we've practiced looking at some equivalent and non-equivalent fractions, let's now try with a word problem. And Miss Dennis is just going to move herself over so we can take a closer look at our word problem. And remember, our objective is to recognize and show that equivalent fractions refer to the same point on a number line. So let's look at our word problem together. It says Nick walked 2/4 of a mile and Ed walked 4/8 of a mile. Did they walk an equivalent distance? And equivalent means equal. You got it. So did they walk an equal distance? Well, let's set up our word problem, right? So we have to go back and we look at the numbers and we think about what is the question asking us. So if I had to set up my word problem, I'm first going to draw two number lines. One number line I'm going to break into fourths because Nick walked 2/4 of a mile. And my second number line I'm going to break into eighths because Ed walked 4/8 of a mile. So let's set up our number line. I'm first going to label it from 0 to 1, both of them. And then I'm going to label the parts on my number line. So I know this is 1/4, 2/4, and 3/4. And we know that 1 is 4/4, okay? Or 1 whole. Now let's label our second number line. We have 1/8, 2/8, 3/8, 4/8, 5/8, 6/8, 7/8, and 8/8, or 1 whole. So now that we've labeled our number line, now let's label our points to mark the distance that both Nick and Ed had walked. So we know that Nick walked 2/4 of a mile. So I'm going to put a circle where it says 2/4. Now I know that Ed walked 4/8 of a mile. So I'm going to put a circle at 4/8. So now I have to think, is 2/4 equivalent to 4/8? Well, yes, because if I look at my number line, the 2 points are on the same point of a number line, right? They are lined up, which shows that they are equal. So, doesn't pictures say 1,000 words? When you draw out your number lines to help you solve problems, it just makes everything that much clearer. So, now it's your turn. Miss Dennis wants you to get out your notebook or get your whiteboarding, your dry erase marker, and solve the next few problems. So now it's your turn. Let's take a closer look at your word problem. Miss Castro and Mrs. Dennis participated in a marathon. Miss Castro ran 3/6 of a mile, and Miss Dennis ran 1/2 of a mile. Who ran a greater distance? So, I want you to think about, and Miss Dennis is just going to, because either way, we need to see if they ran an equal distance. So if Miss Castro and Miss Dennis participated in a marathon, and Miss Castro ran 3/6 of a mile, and Miss Dennis ran 1/2 of a mile, who ran a greater distance? So I want you to pause the video here, scholars, and come back as soon as you are finished. Make sure you draw your two number lines, you label your number lines, and remember what the question is asking us to do. And when you come back, we will check our work together. Okay? Great. Okay, so now that you're back, let's go back and check our work. So first, let's review our word problem. It says Mrs. Castro and Mrs. Dennis participated in a marathon, and Mrs. Castro ran 3/6 of a mile, and Mrs. Dennis ran 1/2 of a mile. Who ran a greater distance? So let's look at how we needed to set up our word problem. First, we're going to draw two number lines. We're going to break the first number line into halves because Miss Dennis ran 1/2 of a mile. And we're going to break our second number line into 6 parts, right? Because Miss Castro ran 3/6 of a mile. Then we're going to label both of our number lines. We know that this is 1/2, right? Or 1/2 parts. And then this would be 2/2 or 1 whole. And then we're going to label our second number line. So we have 1/6, 2/6, 3/6, 4/6, 5/6, and 6/6 or 1 whole. So now I hope you went back and then you thought, well, Miss Dennis ran 1/2 of a mile. And I'm going to put a red dot on 1/2. And then Miss Castro ran 3/6 of a mile. So I'm going to put a little red dot on 3/6. So if I look, did they run the same distance? Are both of the points on the same part of the number line? Is 1/2 equal to 3/6? Well, let's take a look. Are they lined up? Yes. So we know that Miss Castro and Miss Dennis ran the same distance. Excellent job, scholars. So now I want you to try these next few problems on your own. I want you to label each fractional part of the second number line. The first one is done for you. Then I want you to identify the equivalent fraction for 4/8, or the one that has this blue circle on the top. So I want you to pause the video here, and let me just move over so we can see our directions. So now I would like for you to pause the video here, and I want you to try to do two things. You're going to label each fractional part of the second number line, and then you're going to identify the equivalent fraction for 4/8, or the part of the number line that has the blue circle. And then when you come back, I'm going to show you another problem. And then at the end of our video, I will show you the answer so we can check our work, okay? Great. Okay, here's our second problem. So I want you to label each fractional part of the second number line, and then I want you to identify the equivalent fraction for 2/6. Well, we are actually going to label the equivalent fraction for 2/3. Because if we look here on our number line, 2/3 has the blue circle. So I want you to find the equivalent fraction to 2/3. Okay, scholars, welcome back. Now let's double check our work. So if we had to look, we wanted to find the equivalent fraction for 4/8, and we wanted to label the second number line. So we know the second number line is broken into 1, 2, 3, into fourths. And so when I label my number line, I'm going to put 1/4, 2/4, and 3/4. And we want to find the equivalent fraction for 4/8. So we know equivalent fraction means that it has the same point on a number line. So where would I place my second point? Absolutely, 2/4, because that means that they have the same point. So 4/8 is equal to 2/4. Make sure you check your work. How'd you do? Good? Great. Now let's check our work for the next one. So as we know, we are looking for the equivalent fraction for 2/3. So first we had to label our second number line. So we see that it's broken into 1, 2, 3, 4, 5, 6. And so we're going to label each part 1, 6, 2, 6, 3, 6, 4, 6, and 5, 6. And so if we're looking for the equivalent fraction of 2/3, we know equivalent fractions means that it's the same point on a number line. So we would place our blue circle where it says 4, 6. So 2/3 is equal to 4, 6. So make sure you double check your work to see if you place the circle on the same point of the number line. Okay? How'd you do? Great. So this is the end of our lesson for today. I had such an amazing day of teaching and learning with you, and I want you to remember to use Zern and Reflex Math, because when you use these programs, it only helps you become a better mathematician. So we learned a lot today, and I cannot wait for us to learn more in Peak Flicks Math. I'll see you tomorrow, scholars. Bye.